The first step in applying the stiffness method is to measure the number of kinematic degrees of freedom. To do so, we first see how many ways the nodes can move. In general, a node can move in 3 ways. It can move horizontally, it can move vertically, and it can rotate. However, subnodes are restrained, and these restraints reduce the number of degrees of freedom. For instance, a fixed end eliminates horizontal translation, eliminates vertical translation, and eliminates rotation. A pinch support allows rotation but eliminates horizontal and vertical translation. A roller is going to allow horizontal movement and rotation but eliminate vertical movement. Let's see some examples. In the first example, there are no degrees of freedom because both nodes are fixed and cannot translate in either direction or rotate. In the second example, if we add an intermediate node in our model, that node can move horizontally, vertically, and can rotate. Now these two examples represent the same physical problem. However, we note that the number of degrees of freedom depends on our modeling decisions, so we can add more nodes to provide greater detail at the cost of making the problem more difficult to solve. If we look at the third example, it's a cantilever beam. There are no degrees of freedom at the left end because it's a fixed end, and we have horizontal, vertical, and rotational movement at the right-hand node. If we look at the last example, the first node on the left has no degrees of freedom because it's a fixed end. The second node is a pin. It only has rotational degree of freedom. And the roller on the right has horizontal translation and a rotational degree of freedom.